Hello, Sir Parts Online subscribers. Welcome to Sir Parts I Teach Information Technology Teaching. And we are here in our series Learn Machine Learning in W3 Schools. I'd like to thank my students in Introduction to Data Science because this video is made possible because of them. And also to our subscribers who are interested in learning information technology. And please do not forget to subscribe, ring the bell, and comment so that you could get the latest videos of Sir Parts Online. And you can help us. You can help us in improving our channel. Okay, so let's start with our topic today. I hope you're doing great, guys. Okay, so let's go to W3 schools. Now we have this is our last topic. It's all about scaling, no? And our next topic is train test. Okay, train test. Evaluate your model. In machine learning, we create models to predict the outcome of certain events, like in the previous chapter, where we predicted the carbon dioxide emission of a car when we knew the weight and the engine size. To measure if the model is good enough, we can use a method called train test. Okay, so what is train test? Train test is a method to measure the accuracy of your model. It is called train test because you split the data into two sets, a training set and a testing set. So 80% for the training and 20% for the testing. You train the model using the training set. You test the model using the testing set. Train the model means create the model. Test the model means test the accuracy of the model. So start with a data set. Start with a data set you want to test. So our data set illustrates 100 customers in a shop and their shopping habits. So that is our data set, guys. 100 customers in a shop and their shopping habits. So this is the code. Import NumPy. So we use the NumPy here. And we also use the matplotlib pyplot. So import matplotlib.pyplot as PLT. Then numpy that random said 2. Then you have x equals numpy that random normal 3 1 100 and y equals numpy random normal 150 40 100 divided by x. PLT that scatter xy PLT show. So result, the x-axis represents the number of minutes before making a purchase, and the y-axis represents the amount of money spent on the purchase. So there you go. This is our scatter plot, and we can run this one. We can run this example so that we could see our output. So if you're going to run this again, normally it would create another. Okay, let's try to see the result after running it again. There you go, guys. Uh, okay. Import sys, import matplotlib, matplotlib.use agg. These are normal now. We know already about this one. Then we import numpy, import matplotlib plot as plt, numpy.random.seed2. Then the x, we have the random.normal, 3, 1, and 100. Y, numpy random.normal, 150, 40, 100. Okay, and save the picture. Okay. Okay, then we need to split into train and test. The training set should be a random selection of 80% of the original data, and the testing set should be the remaining 20%. So this is how you're going to do it. Train underscore x equals x, that is 80%, and train underscore y equals y colon 80. So these are our train values. And for our test, we have 20%. That should be right as this one, 80 colon 20. Okay? And that is also the same as with test underscore y. Then display the training set. So display the same scatter plot with the training set. PLT, scanner, train X, train Y, PLT show. So it looks like the original data set, so it seems to be a fair selection. It looks like now. Then display the testing set. To make sure the testing set is not completely different, we'll take a look at the testing set as well. So PLT scatter, test X, test Y, the PLT that shows. So this is the result, okay? And we are going to fit the data set. What does the data set look like? In my opinion, I think the best fit would be a polynomial regression. So let us draw a line of polynomial regression. To draw a line through data points, use the plot method of the matplotlib module. So this is the example, guys. To draw a polynomial regression line through the data points. Okay, okay, that's the code. Import numpy, import matplotlib.pyplot as plt, numpy.random.sed2, x equal numpy.random.normal 3, 1, and 100, y equals numpy.random normal 150, 40, and 100. Then we have train x, that is 80% of the ax, and train y, 80% of the y. Then you have the test x, that's 20%. And test y is the another 20%. Then you have the my model, which is equivalent to numpy.polyid, numpy.polyfit, train x, train y, comma 4. And you have my line, numpy.lenSpace 0, 6, and 100. And PLT scatter train x, train y, PLT plot my line, my model, my line, PLT dot show. This would be the result. The result can back my suggestion of the dataset fitting a polynomial regression, even though it would give us some weird results if we try to predict values outside the dataset. Example, the line indicates that a customer spending 6 minutes in the shop would make a purchase of 200. This one, guys, we can predict, no? That is probably a sign of overfitting. But what about the R-squared score? The R-squared score is a good indicator of how well my dataset is fitting the model. Okay, R-squared. Remember R-squared, also known as R2 or also known as R-squared? It measures the relationship between x-axis and y-axis, and the value ranges from 0 to 1, where 0 means no relationship and 1 means totally related. The sklearn module has a method called R2 score that will help us find this relationship. In this case, we'd like to measure the relationship between the minutes of a customer stays in the shop and how much money they spend. So how well does my training data fit in a polynomial regression? So you have here, import numpy from sklearn.metrics, import R2 underscore numpy.random.sid2, x equals numpy.random normal 3, comma 1, comma 100, y numpy.random normal 150, comma 40, comma 100 divided by x. Then you have train x equals x 80%, train y equals y 80%, test x equals x, that is 20%, test y, test underscore y is equal to y of 20%. My model equals numpy.polyid, yeah, polyfit train x, train y, comma 4. R squared equals R2 score train y, my model train underscore x. Then you're going to print the R2. The result is 0.799, shows that there is an okay relationship. Then bring in the testing set. Now we have made a model that is okay, at least when it comes to training data. Now we want to test the model with the testing data as well as to see if it gives us the same result. So let us find the R2 square when using the testing data. So import numpy from sklearn.metrics, import R2 square, numpy.random sid2, x equals numpy.random normal 3, comma 1, comma 100, y equals numpy.random normal 150, comma 40, 100 divided by x. Then you have train x, train y with their values 80%, train test x, test y, x and y values would be 20%. My model equals numpy poly ID empty polyfit train X comma train Y underscore 4. R squared equals R2 score divided by test over Y, my model test underscore 2. Print R2. So the result of 0.809 shows that the model fits the testing set as well. And we're confident that you can use the model to predict the future values. So predict values. Now that we have established that our model is okay, we can start predicting new values. Example, how much money will a buying customer spend if she or she stays in the shop for 5 minutes? So the example predicted a customer to spend $22.88 dollars seems to correspond the diagram. Okay, so that's it, guys. Thank you very much for watching, and I hope you learned something in our train test. And yeah, you can use this one for your example in making your videos. Thank you very much, guys. See you in our next videos. Bye, everyone. Always remember, learning is lifetime. Bye bye.